All right, so in this example, we're asked to find all 6 trig functions for the angle 7 pi over 6. Now, the difference here is that we're actually told this angle's measure. What are we not told? We're not told any ordered pairs or any points that are going to be on this angle's terminal side. So the first thing I think we want to do is actually go ahead and graph this angle and see what it looks like. Now to do that, I think it might be a little bit easier to put this guy into degrees instead of radians. So I'm thinking 7 pi over 6 radians. And I think, well, I can write this as 7 times pi over 6 radians. And I know that pi over 6 radians equals 30 degrees. So I think we're going to have 7 times 30 degrees for a grand total of 210 degrees. Now it's important to have an idea of what this angle looks like as well. So I'm going to go ahead and insert a set of axes here. And we're going to use these to draw our angle and then evaluate the trig functions. So for instance, I know that our angle is going to have an initial side that goes directly along the positive x-axis. Now I know that this is 180 degrees. And so 210 degrees is just going to be 30 degrees farther this way. So we'll draw the angle as such. So here's our angle, 7 pi over 6, or 210 degrees, whichever one you want to call it. Now, the thing is, all right, we've got the angle. We know what it looks like. Woohoo! But we need to find an ordered pair or a point on the terminal side. And we can use this guy's x and y coordinates to evaluate sine, cosine, and tangent, and the others of our angle 7 pi over 6, or 210 degrees. Well, how are we going to go about doing that? Well, I think it's a great idea to draw a reference triangle. So I'm going to go ahead and I'm going to drop a line from that ordered pair, we don't know what it is yet, to the x-axis, and we've created a right triangle. And now what I think we've actually done is we've created a special right triangle. Because, like we said, if this distance, or rather if this angle right here is 180 degrees, and this angle right here is 210 degrees, then it means that we are dealing with an angle right here of just 30 degrees. Meaning this angle down here must be 60 degrees. We've got a special right triangle on our hands. We've got a 30, 60, 90 right triangle. And we've dealt with these ones before, and we can assign lengths to these 3 sides of the triangle. And so the first one I like to do is I say, you know what? The shortest side of this triangle, we're going to assign it a length of 1. And when we do that, the longest side of the triangle, which is of course the hypotenuse, has a length of 2. And the middle side is going to have a length between them, the square root of 3. And so once we do that, we go, boom, you know what? We know exactly what the coordinates are for this point right here. That coordinate is going to be negative root 3, because our x coordinate is going to be negative because we're to the left of the y-axis. And this length is root 3, so we've got the ordered pair negative root 3, comma, negative 1. So both our x coordinate and our y coordinate happen to be negative here. And you know what's really great? We've already got our radius. We've already got that value r. We are totally ready to find the sine, cosine, and tangent of 210 degrees, or 7 pi over 6 radians. And so, let's say that the sine of 7 pi over 6, well, that's the y-coordinate over r, and the y-coordinate in this case is negative 1, so negative 1 over 2, we get something very nice, negative 1/2. The cosine of this angle will be the x-coordinate over the radius. The x-coordinate is negative root 3, and our radius is 2. There we go, negative root 3 over 2. And the tangent of this angle, 7 pi over 6, is equal to the y-coordinate over the x-coordinate. So negative 1 over negative root 3 or we can just simplify that fraction as, just positive 1 over root 3. And so we have found the sine, cosine, and tangent of this angle whose measure we were given. And in general, whenever we're given the measure of an angle, I'll tell you now, it's always going to be one that you can create a 30, 60, 90 right triangle or a 45, 45, 90 right triangle by dropping this perpendicular and drawing a right triangle. And so that's the strategy for doing these.